This is lessons 5.3 and 5.5. So since we don't want to have to prove every single side is congruent and every single angle is congruent in triangles to prove that they're congruent, we're going to learn some shortcuts, and there's going to be 3 that we learn today. The first 2 are side, side, side congruence, or SSS, and that's if you know that all 3 pairs of sides match, you're good. You don't need to know anything about the angles to say that the triangles are congruent. The second one, and the one that's a little trickier to get wrong, is side angle side, or SAS congruence. So this one is triangles are congruent if 2 pairs of sides and the included angles are congruent. What that means is if I were to trace the 2 sides that we have marked as congruent, it points to the angle that was marked as congruent. It cannot be an angle P or S that's congruent. It has to be the one between or included in those 2 sides. It sometimes helps if you want to label any dash with an S and any curve with an A, and we read it in the order that it appears. That is SAS in the picture. So why can't we use one of the angles that's not between the sides, right? Why not SSA? Besides the fact that it's a bad word backwards, and ASS is also not going to work for us. In my diagrams here, I do have 2 sides that are congruent, and I even calculated the measurements in my little math program. I do have an angle that's congruent, and it's not between them, and you could see that these triangles are not the same. That third side, CB in this one, is much longer than that third side, FD in this one. So just knowing the 2 sides and the other angle, the non-included angle, are congruent is not enough information to say that the triangles are congruent. There is a little video linked here if you wanted to type that URL in from Khan Academy that gives a more in-depth explanation as to why SSA does not work, but just know that it will never ever work for us in these triangles if that's the only information we know. There's one extra piece of information they can give us which would make it work. Just one extra piece of information, and that is when the angle that they're saying is congruent is a right angle. So we have a different name for that scenario because it only happens in these right triangles, and it's called hypotenuse leg, or HL. So normally I would have been marking this as S, S, and A, and we can see it's not going SAS like this. It's going more ASS or SSA. So instead, if that's what happens, we're looking more at it as the side across from the right angle is the hypotenuse, and one of the other 2 sides is a leg of that right triangle. So this would qualify as HL. Not all right triangles need to use HL for their congruence, but only right triangles can be used with HL congruence. So every time we're asked to show whether or not triangles are congruent, there are certain things we know to be true, whether they have told us or not. So in the first one here, we see that we have a triangle ABD and we have a triangle CDB. Both of them contain this side BD. So I would be able to mark that as a congruent side because it's not changing its length when it goes from one triangle to the other. So that shared or reflexive, I call it reflexive because we're saying BD is congruent to BD, and that's the reflexive property. So this is a shared or reflexive side that we are automatically about to mark, and if I was doing a proof, I would state that step in the proof and mark it in my picture. The next thing is vertical angles. We always know that vertical angles are congruent by the vertical angle theorem, so I can go ahead and mark them in any of my pictures, and if I'm doing a proof, I can include that step in the proof. And if we are told lines are parallel, we can have corresponding or alternate interior angles. I only drew 2 scenarios. There is the third scenario of our bow tie, which I mentioned in a different lesson, that we would have alternate interior angles in a bow tie. We would have alternate interior angles in a shape that looks like a box or a parallelogram. And we would have corresponding angles. Oh, I'm going to do this one wrong. Hold on. Our parallel lines have to have a common transversal. Yep, so that was right. I wasn't wrong. So those would have been corresponding angles for those parallel lines. So for our first 4 problems here, we're going to first look at each picture and mark those kinds of things that we know we're allowed to mark, like this shared side here, these vertical angles here, this shared side here, and I see with these parallel lines, they have the common transversal, so I can mark these angles as congruent according to the corresponding angle postulate. So now that I've done that, I'm going to figure out what the method is for why these triangles are congruent, or are they not congruent, explain why. And if they are congruent, I'm going to finish the congruent statement. So they already started it for me, I'm going to finish it. So in this one, I see I have 3 sides and 3 sides. So this is an easy identification of SSS. And now my congruent statement, GAD. So G was between my 1 mark and my 2 mark. I'm going to mark the angle for myself right now because across from it, between the 1 mark and the 2 mark, would have been J. So I know G matches with J. And then I went to A. A is between the 1 and the 3. So between the 1 and the 3 is also A. And then D matches with D. So that is my completed congruent statement. In B, I have this is a side, this is a side, this is an angle, this is a side, side, that was an angle. So in one triangle, it looks like SAS, it's the 2 sides, and if I connect them, it points to the angle that I wanted. But in the other triangle, when I take the 2 sides, it's no longer pointing to the angle that I wanted. So these 2 triangles don't match with each other. So this is no. The triangles don't match. In C, I have a side, ooh, that's a terrible S, and an angle, a side, and an angle. So this looks like SSA again, which we know isn't allowed, but I do see that right angle there. So SSA with a right angle is really HL, hypotenuse leg. So BEH, I started at the top here between 2 and 1. B is between the 2 and 1 again. Then I went down the 2 to the E, so I'm going to go down the 2 to the K, and then back to the H. All right, this last one, that's a side, that's a side, that's an angle, that's a side, that's a side, that's an angle. So I do have 2 sides and an angle. If I connect the S's, it points to that A. Connect the S's, it points to that A. So this would be SAS. And NQT, so N was the congruent angle. So we're going to start with T, which is the congruent angle. Then I went down the parallel side to Q, so we're going to go down the parallel side to Z, and then finish it off at W. So here's the first try. Pause if you'd like. The answers are posted online. For example 2, we want to state what additional information is needed to prove that the triangles are congruent using the given method. And we're going to mark it in the diagram. So just like before, the things we already know are congruent, we can mark. Nothing additional to mark here. That is not the thing I'm going to state because that's something I know. It doesn't need to be stated right now. The third thing we would need to get to the method for A, so we have a side, we have an angle, we want to do side, angle, side. So I need the other side to be touching this same angle. So let's look at this angle here. This line and this line are going to be the 2 lines that touch that angle. So here's a side that we need. And same thing here. If this side and this side are the 2 that point to that angle, this is a side that we need. So that would have been segment KG is congruent to segment JI. And that is the additional information that would be needed to prove using SAS. For B, we want to use SSS. Well, we already have 2 sides, so we just need the third one. So that would be segment VX is congruent to segment KM. And then our third one is HL. So we know that they're right triangles. We could add another right angle there if we'd like. We have a leg so far, right? This is not across from the right angle. This is the leg. So we need the hypotenuse. So across from this right angle is CB. and across from this right angle is DD. So that would be the additional information that we need to prove by HL. So for try 2, if you'd like to pause and give it a shot, the answers are posted online. And now what you've all been waiting for, proofs. All right, chapter 5 is a very, very proof-heavy chapter because everything is about proving triangles congruent. And that's what we're going to do in this problem. We're given some information, and our ultimate goal is to prove that these two triangles are congruent to each other. So the first step is a given, and let's fill in all of our givens right now. We have B as the midpoint of AP, and we also have that MB is perpendicular to AP. So after we said that B was the midpoint of AP, we said that AB and PB are congruent. So because it was the midpoint, we would use definition of midpoint. I'm going to abbreviate that a little bit. And then the next step is that segment BM is congruent to segment BM. So that's here. When you say something is congruent to itself, we are using the reflexive property. Then I have that MB was perpendicular to AP, and after that, I'm calling the two angles formed by those perpendicular lines right angles. That is actually the definition of perpendicular. What it means to be perpendicular is that it forms right angles. And this one is one that we haven't used much, but it is something we learned. If I know two angles are right angles, I'm able to say they're congruent, and there's two reasons I can write here. I can either write the right angle congruence theorem, or it would be okay to just write the phrase right angles are congruent. Actually, it's one more letter, one more character here than it would have been here, but it's the same exact thing. It doesn't matter what you call it, we're fine with either. So now if I look at my picture, I have enough information to say the triangles are congruent because I have two sides and the angle between them. So this would be SAS. It's not HL, even though they were right triangles, because we didn't have the hypotenuses that were congruent. For example 4, we have some of the steps, but not all of them. So we do know that step 1 and step 3 are both listed as given. So they've marked BD and FD for us. If D is the midpoint of CE, then I know I can split CE into two equal pieces using the definition of midpoint. So that would make segment CD congruent to segment ED. And then they tell me that angle BCD and angle FED are right angles, given. Here's a step that you might not know you need to use, because usually when you see that two angles are right angles, you might want to try to say that those angles are congruent. But if I look at my picture and I figure out what is going to be the way that I'm saying that these triangles are congruent, this is looking more like an ASS or SSA situation with a right triangle. So that tells me I'm actually going to use HL as the reason the triangles are congruent. So that brings me back a step. If I'm going to use HL, because HL can only be used in right triangles, I'm going to include the statement in my proof that they are right triangles. And I can only do that after I've mentioned that there are right angles. So I'm saying that triangle BCD and triangle FED are right triangles, and that's by the definition of right triangle. And now I'm able to use HL. So anytime you want to use HL in a proof, we're going to need to include the step that those are in fact right triangles. So here's a proof for you to try. Pause if you'd like. Answers are posted online. If we've already proven triangles are congruent, we can say any of their matching or corresponding parts is congruent, and we're going to use CPCTC. Corresponding parts of congruent triangles are congruent. We are definitely going to abbreviate it to CPCTC, but I will tell you that if you miswrite this, if you write like CTPTC or something like that, you're going to get it wrong. Even though I know that you know what's being used, you don't know what it means if you're using that. So we do need to know that it's standing for the fact that those matching pieces are the same because the triangles are the same. So that's why we're using corresponding parts of congruent triangles are congruent. This will be used immediately following triangles being congruent in a proof, right? So if step 7 was that triangle ABC was congruent to triangle DEF, by whatever method we used, say it was SSS, then I can say in the very next step, one of their angles was congruent, right? The matching A with the matching D, and that would have been by CPCTC. So for example 5, we are given that segment MN is congruent to segment PN and segment LM is congruent to segment LP, and they've already marked it for us in the picture. If I were just looking at this problem and I wanted to figure out how the triangles are congruent, I would have marked this side. So if I would have marked this side, I'm going to include it in the proof. Ln is congruent to Ln, and anytime you say something's congruent to itself, that is the reflexive property. I actually see 3 sides already in this picture. So this is looking a lot like the example I just talked about. So we're going to be able to say the 2 triangles are congruent by SSS. So let's be careful how we write our congruent statement. I'm going to say LMN is congruent to, so L was between 1 and 3, L is between 1 and 3, M was between 1 and 2, P is between 1 and 2, and then N with N. I'm going to jump ahead to my proof statement for a second, and I'm going to say I want to prove that this segment here cuts angle MLP in half. In order for me to say that MLP has been cut in half, I should know that these 2 angles are the same. Those 2 angles happen to be corresponding angles in my congruent triangles. So let's say that angle MLN is congruent to angle PLN by CPCTC, which now allows me to say that it bisects it by the definition of bisects. So in step 3, we had the fact that triangles were congruent. Immediately following it, we used CPCTC as our reason to say one of their parts was congruent. Here is our final try problem. Pause if you'd like. Answers are posted online. But that is the end of sections 5.3 and 5.5.